Exercise 3. Prove using induction that the sum of the first n squares equals 1 over 6n plus 1 times 2n plus 1. Well, we define this as a statement over the natural numbers. Pn is the statement that the first n squares equals 1 over 6n times n plus 1 times 2n plus 1 for n being a natural number. So we have different steps to take. The first step is showing that in the beginning of our sequence of statements we have a valid statement P1. So we need to show that P1 is true. So we substitute n is 1, so we get the sum of k is 1 to n. K squared equals 1 squared is 1 equals 1 over 6 times 2 times 3. Yeah, you see that actually this makes a correct statement. So the first step is true. So the first step we've shown that P1 is true. Now we consider step 2. So suppose Pn is true. Pn is true for some value n hat. N hat in n. So this means that actually, if we substitute n hat for n, we get the sum of the first n hat squares equals 1 over 6 n hat times n hat plus 1 times 2 n hat plus 1. This is the induction hypothesis. So now we want to check the validity of Pn hat plus 1. Well, the sum of the first n hat plus 1 squares equals the sum of the first n hat squares plus n hat plus 1 squared. So now we apply our induction hypothesis. So we write the first sum as 1 over 6 n hat times n hat plus 1 times 2 n hat plus 1 plus the remaining term n hat plus 1 squared. So what we do now is take out the common term n hat plus 1 from both terms, and we'll see n hat plus 1 times 1 over 6 n hat times 2 n hat plus 1 plus n hat plus 1, the remaining term of the second term. So take out 1 6, then we n hat plus 1, and we get a remaining term as follows. We can even simplify this more, so n hat plus 1 times 1 6 times 2n hat plus 7 n hat plus 6. And this quadratic term allows for factorization. So we get n hat plus 1 times 2 n hat plus 1 plus 1. So this is actually what we get if we look at the general statement Pn and substitute instead of n hat plus 1. So what we find is if we assume Pn hat, that we may conclude that Pn hat plus 1 is true. So now we have two steps. P1 is true, and from Pn we have Pn plus 1 for all n. Yeah, so we have two stages. So now we can conclude that the domino effect works, so the first stone will fall, and if the nth stone will fall, the n plus 1 stone will fall. So this means that the whole sequence of infinite domino stones will fall. Then by induction we see that Pn is true for all n.